Hi, everyone. Welcome to Data Science Connect. I hope you're having a great time so far. I'm going to go ahead and talk about image search, or often called visual search, which I'll go into a bit later, but I think is a big part of adding back interaction and excitement around the online discovery experience, especially for customers of e-commerce products. So I hope you'll enjoy this presentation and have some questions at the end. I'll try and answer everything in the chat. So thanks. Just to get started, I think, from the name image search, it's a little bit self-explanatory what that means, but let's go through some examples in the industry right now. So here on the top left, you'll see an image from Bing Image Search, where if we just search suits, then we can click on one of these images and actually look through similar items that we can shop for all of the products that are auto-detected in this image. So this is just built into Microsoft Bing's image search functionality, which is very cool. Amazon as well, obviously another big e-commerce company, has a new product that they've brought out called Style Snap. And it's a very similar thing where we can actually upload our own custom images and then click through the products that are auto-detected in the image and see similar products that are shoppable on Amazon specifically, since this is an Amazon product. So some really compelling examples of very, big name, big e-commerce companies using this functionality in the real world. So who am I and why am I talking about this? My name is Morgan. My pronouns are she, her, and I'm currently a data science and machine learning manager who has worked in the e-commerce space at several different companies now. So I've seen a lot of examples of how people interact with product and how we can kind of label all of these products coming in a way that makes it easier for our customers to explore and use. And I'm going to talk about, some of the learnings and also options for those different systems in image and visual search today. Cool. So let's jump in with some use cases of why is it so important that we be using this? Why might customers want to see this? So there's a ton of them, but here are kind of the big three that I think are very compelling. First off, out of stock. If someone, falls in love with a particular item, whether that be a dress or a jacket or a piece of furniture, if it is out of stock in their size or out of stock completely, we still want them to be able to find either the exact same item or a very similar item that they can purchase and use when they already have that high intent desire to purchase something in particular. Also, in-person sightings. So in-person used loosely here to also mean on social media, because I do think that's a big way we discover new products or kind of get inspiration for new items today. But whether it be a picture from a social media site or a picture in real life of a friend wearing an item or a friend's couch that they can't remember where they bought it, how can we turn those kind of in-person images into real shoppable products? Similar to the two examples we saw earlier. Another is similar items. So I think you'll see when people are shopping, sometimes they need a product to be delivered in 2 days and the one they're looking at can't come in 2 days. Sometimes they need something that costs less. Sometimes they need, it's not the perfect item and they need something similar. So can we show them, a very similar product or the same product that will kind of fit those boundaries and limitations they have. They already know they want to purchase the item, but again, there's some sort of barrier, and how can we remove that by showing them other options? So these are some of the big use cases I see generally for image or visual search, and I think can be really compelling ways to help users explore and discover new items and continue their shopping experience online. So moving right along, I think one of the big questions here is why build it yourself? There's a ton of third-party options for stuff like image search. And I think some of them are very compelling and are great kind of first steps for a lot of companies looking to get into the image or visual search space. But there are a couple reasons why that might not be super sustainable in the long term, or why we might want to transition into something that we build in-house at our own companies. This is not necessarily the answer for everyone, but this might be, some reasons you explore. First of all, there's kind of faster catalog availability. So if you have your own product catalog or you're getting product catalogs from retail partners or something like that, as soon as you get the update, you can kind of integrate this into your own image search platform and allow kind of near real-time exploration of new products. Whereas in a lot of third parties, either you can only update the catalog once a day, or there's a limitation for how quickly new products can get into the catalog and be returned. Sometimes it can be cheaper. Some of these products have high costs for the number of requests you send, the number of products they store, and so it can actually be cheaper to, build it yourself. It's also very customizable. So if you want to have filters on price range or, delivery time for specific products, you can do that and build that into your product yourself. And we'll talk a little bit about that later. And it's custom data. So we'll see later in this talk about how we measure similarity and how we're going to figure that out. And if you build it yourself in-house, you get to have huge influence and decision-making over how that happens. All right. So as I just said, we're going to talk about how do we define similar. So the whole point of this is we're saying we're going to take in an item and we want to be able to search for similar images. But what does it mean for two images of two different products or the same product? What does that mean to be similar? So models already do this for us. When we are trying to classify products, what they're doing is they're actually saying, how do we represent each of these products in a way that demonstrates which ones are similar based on the classification we're doing. So if we have a model that is going to label things as either a chair or a table, it's actually going to learn to represent these images in a similar way so that they are in space close together, and it can then figure out which label should be appointed to each one. So it's kind of a built-in functionality of a lot of machine learning models, is that what it does is it makes a representation of these vectors you see here, saying this is where I'm representing this product or this image in space based on what I've learned of how to transform these images into a vector in order to figure out which label it belongs to. So when we train models to do this classification work, it also comes with this kind of embedded vector that is explaining to us from this context of this specific classification problem, which items, which images are most similar to each other. So we can then take this and use that to actually be searching their entire catalog later. But let's start off small. So we obviously have to figure out what kind of model structure are we going to want to use to do this labeling. And honestly, this isn't, maybe the most helpful answer, but the answer really I've seen is to experiment, to iterate, to be continually kind of using different model structures and seeing what works best for each of your different use cases. So that might be starting with an off-the-shelf model, that might be building a custom model, that might be using different kinds of deep learning techniques and trying to figure out which architecture is really completing that classification task best for the use case that you have. And that's one of the great options about this system that we're going to talk about, is that you can be continually iterating, experimenting with new models, and just kind of substituting them in as needed. So here's kind of an example of, in a PyTorch model, how you might pull out that vector. So this is actually an example from a former coworker that is on GitHub. So you can go to this link and check it out. But I did want to call out some here. So here you see how we are kind of registering a hook in PyTorch, and we're using that to pull out that embedding or that vector from the originally trained model. So, this will work for kind of all different kinds of PyTorch models. We train the model, and then we're able to pull out that embedding vector that we talked about earlier that we can use later. And again, you can go to this link to check out kind of more details about that and more information there. Cool. So now that we've talked a little bit about how to get the vector out and what kind of model we want to use, what do we even want to classify? And again, the answer here is a little bit going to be, it really depends on your use case. So these are some examples of classification models you might train. So you might train a model to determine the pattern of a product. So we take in a dress or we take in a chair. Can we determine, is that a solid pattern? Is it striped? Is it polka dot? Is it leopard print? There's all these kinds of options of we can train a model to label the pattern of the fabric of the product. We can do a very similar thing for color. So, is it blue? Is it red? Is it beige? And through that, the model is learning to create these embeddings where similar embeddings have similar structures. So when we pull out those embeddings and can compare them, we're actually saying how similar is the color of these different products, of these different images. So that can be a really compelling way to determine similarity. Another one is taxonomy. So we've already talked about we could do this with dresses, with jackets, with chairs. Obviously, those things really determine what is similar and what is not. So we can train a model to classify all of our different products as different taxonomies and tell us which one's a lamp, which one's a chair, but also to get us that embedding. So again, similar embeddings for this model will be things that are similar taxonomy, so kind of similar shape, similar place in a product catalog of, two lamps will have much more similar embeddings than a lamp and a chair. So these are just 3 examples. There's tons out there. You could do occasion, you could do style, aesthetic, season. There's so many different options. These are kind of just 3 I picked out as maybe compelling ways of determining what 2 products are similar and things people really look for when they're looking for a similar product. All right, so let's say we pick taxonomy and color. We have all these different products in our product catalog, and we trained up a model. We ran all of these products through both a taxonomy model and a color model, and we pulled out that vector embedding so that we can compare them and see what looks similar. So this top one here in the blue is a taxonomy model, and the bottom one here is the color model. So as you'll see, like chairs should have more similar vectors for the taxonomy model. 2 items that are the same color scheme or color in general should have more similar vectors from the color model. So we can really use these embeddings and compare them to say, which ones are more similar in these different aspects, or take all of them and say which ones are more similar based on all these different classifications that we made. Okay, so we have all those products. What are we going to do with them now? How are we actually going to run that comparison and see which ones are more similar? Again, the answer is we have options. So one that I've seen worked really well is Spotify's annoy or approximate nearest neighbors. So this is like a small picture of what that looks like, but some benefits here are that it is open source and it's very easy to set up without operations experience. So what you can do here is you can upload all of those different embeddings and then quickly compare them against each other to see which ones are most similar. Another option I've seen work really well is Elasticsearch. And so the reason, this can be really beneficial, again, it is an open source product. It's very easy to add new products. You can very quickly just include another product with its embeddings, and it's very fast to do that. It's also extremely scalable because of the elastic compute, as you might be able to tell from the name. And it's very quick for searching and filtering. So it makes that real time, I have a new product and I want to get back similar items, a very fast process, which is obviously hugely important if you're trying to integrate this into something like a website or an app where people aren't really willing to wait a long time to get their results. So I've seen this be a very compelling use case for storing all of those embeddings and then quickly doing a comparison. All right, so now we have this database where we're storing all the products, we're storing all of the embeddings for those products, and we need a way to quickly pass in a new product and get back those results. And so to do this, we'll add an API endpoint where all of that work is in a Docker container, and we can quickly just query the endpoint to get back those results. So this could be something that's developed in Flask, something that's developed in Fast API. There's a lot of options for kind of RESTful API endpoints that we can create out there. And what this does is do all that processing work of saying, we're going to send in a new product. It's going to go out, send that product through our classification models, get the embeddings, and then quickly query our Elasticsearch database or our Annoy index and say, okay, send me back all of the products with similar embeddings, and this is how I want you to compare them. We'll talk about that a little bit more later. All right, so here's our pipeline as we have it set up right now. So this is just an example of one product, but this will happen with all of our products. We are going to send it into our classification model or models. So in this case, again, we're doing taxonomy and color. We're getting back both the label and that embedding. So we know this item is a chair. We have labeled it as beige. I just made up this color. I'm sure I have found in doing this that color can be a lie, and everyone has very different opinions about what color this is. So if you think this is brown or gray, please don't get too upset with the beige choice. But we also have the corresponding kind of embeddings for the chair and for beige. So what we're going to do with that is we're going to upload it into our Elasticsearch index, and we'll do this for all products in our catalog. So all our products are going to be run through the classification models and then all uploaded into our Elasticsearch index. What that allows us to do is create this API endpoint that's going to say, okay, let's run a cosine similarity of this embedding. So when we pass in a new product, we'll get the embedding for that. We query Elasticsearch and get all the similar results. And then those are presented to the person who hit the endpoint. So we've kind of got this full pipeline of going from, we started with all these products in our product catalog, and we now have a quick and easy way for someone to send in a new product and get back all of the similar, as we've defined similarity, products in our catalog. And the nice thing about this pipeline is if we train up another classification model that does something different, like we want to add pattern in here, or we want to add formality in here, we can just train another classification model, send the products through there as well, and upload that into Elasticsearch. And then we can quickly and easily incorporate that into our similarity calculation and be saying, not only do I want products of similar taxonomy and similar color, but I also want them to have similar pattern. So we can quickly iterate, we can quickly change out the type of classification model we're using here. As long as we're getting back an embedding and putting that into Elasticsearch, the architecture of that actual classification model is very flexible. So a lot of benefits to this. So I want to give one comparison of maybe equal weighting. So here in that API endpoint, we're saying, let's query Elasticsearch, and we're going to run our cosine similarity and say we're going to place equal importance on the taxonomy embedding and the color embedding. So here we'll see that the top ones are kind of similar taxonomy, similar color. And then as we move down, this is a ranked process. As we move down, they'll get kind of less and less similar in both color and shape or taxonomy. We can also do something like, let's heavily weight the color embedding. So say this is a use case where someone might want to, they already have a chair or they just bought a chair and they might want similar colored rugs, similar colored sofa, et cetera, et cetera. And so you might say, like, I'm going to incorporate both taxonomy and color, but I'm going to place a much heavier weight on color. So when we're calculating similarity, the similarity of those color embeddings is going to be maybe 80% of the calculation. We're going to weight it much more heavily. And so here we see, this one is a similar shape at the beginning here. The sofa is a similar shape, similar color, but then very different shapes, but the same color as we can continue down that line. So we've placed heavy importance on color and a much smaller importance on that taxonomy embedding to get a kind of different measure of similarity here. All right, so also one of the huge benefits I think I've talked about of Elasticsearch is filtering. So you might have millions and millions of products in your product catalog, and that can take a long time. Elasticsearch is really fast, very efficient, so you can do these kind of cosine similarity comparisons very quickly, but that's still millions of products. So is there a way we can kind of decrease that? Or a way we can say we want all the same price. We want something that's going to be delivered quickly. So if you put that information into Elasticsearch, so you're telling it not only is this a beige item, but it's also in this price range, you can very quickly filter down the catalog to that. So say that we have this chair coming in and we really don't want to be getting anything that is not a chair. So we're going to say filter down the catalog to just other chairs and sofas. So now we only have a small fraction of the product catalog that's left. And then we have to run those cosine similarities only over that small fraction of the catalog that's left instead of the entire catalog. So this drastically kind of decreases the time that that query is going to take without really degrading our results. So now, we have these scores. This is maybe the exact same item that we had in the product catalog, very similar item, and it's all filtered down just to those chairs and sofas. So this hugely decreases our query time, especially if we have a big catalog. All right, so thank you. I think we are right at time. So hopefully if you have any questions in the chat, I can get to them now. Otherwise, here is my LinkedIn information. So if you do have any other questions or something I didn't touch on or something I can explain more in this talk, please feel free to reach out and ask on LinkedIn. Thanks everyone for coming.